This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory. Exploring the ultimate frontier with our host Dr. J, aka Dr. Joe Liske.
Hello and welcome to this special episode of the ESOcast. Leading up to ESO's 50th anniversary in October 2012, we will showcase 8 special features portraying ESO's first 50 years of exploring the southern sky. Great music, isn't it? But suppose you had a hearing impairment. What if you couldn't hear the low frequencies? Or the high frequencies? Astronomers used to be in a similar situation. The human eye is only sensitive to a small part of all the radiation in the universe. We can't see light with wavelengths shorter than violet waves or longer than red waves. We just don't perceive the whole cosmic symphony.
Infrared or heat radiation was first discovered by William Herschel in 1800.
In a dark room, you can't see me. But put on infrared goggles and you can see my body warmth.
Likewise, infrared telescopes reveal cosmic objects too cool to give off visible light, like dark clouds of gas and dust where stars and planets are born.
For decades, ESO astronomers have been keen to explore the universe at infrared wavelengths. But the first detectors were small and hence inefficient. They gave us a blurry view of the infrared sky.
Today's infrared cameras are huge and powerful. They're cooled to very low temperatures to increase their sensitivity. And ESO's Very Large Telescope is designed to make good use of them. In fact, some technological tricks, like interferometry, only work in the infrared. We've broadened our view to reveal the universe in a new light. This dark blob is a cloud of cosmic dust. It blots out the stars in the background. But in the infrared, we can look straight through the dust. And here's the Orion Nebula, a stellar nursery. Most of the newborn baby stars are hidden by dust clouds. Again, infrared comes to the rescue, revealing stars in the making. At the end of their lives, stars blow out bubbles of gas, cosmic showpieces at optical wavelengths. But the infrared picture shows much more detail. "167,000 years ago, a star exploded in a small galaxy orbiting the Milky Way. At the time of the distant explosion, Homo sapiens just started to roam the African savanna. But no one could have noticed the cosmic fireworks, as the blast of light had only just embarked on its long journey towards Earth. By the time light from the supernova had completed 98% of its journey, Greek philosophers had just started to think about the nature of the cosmos. Just before the light reached Earth, Galileo Galilei trained his first primitive telescopes on the heavens. And on the 24th of February 1987, when photons from the explosion finally rained down on our planet, astronomers were ready to observe the supernova in great detail.
Supernova 1987A flared up in the southern sky, unobservable from Europe or the United States. But by this time, ESO had built its first big telescopes in Chile, providing astronomers with a front row seat to this cosmic spectacle.
The telescope is, of course, the central tool that allows us to unravel the secrets of the universe. Telescopes collect far more light than the unaided human eye, so they reveal fainter stars and let us peer deeper into space. Like magnifying glasses, they also show finer detail. And when equipped with sensitive cameras and spectrographs, they provide us with a wealth of information about planets, stars and galaxies.
ESO's first telescopes on La Silla were a mixed bunch. They ranged from small national instruments to large astrographs and wide-field cameras. The 2.2-meter telescope, now almost 30 years old, is still producing some of the most dramatic views of the cosmos.